Introduction. Click on the multimeter to observe it being used as an ohm meter. In this lesson, you will learn the principle and the use of the Wheatstone Bridge, the principle and the use of the meter bridge, the use of a shunt, the use of multiplier. Why does the water flow from A to B? Answer. Water flows from A to B because the pressure at A is greater than the pressure at B. Click the switch in the circuit. Why does the current flow from A to B? Answer. The potential at A is higher than that at B. Click the switch. Does the current flow from A to B? Answer. No, the potential at A and B are equal. When the Wheatstone Bridge is used to determine an unknown resistance R, the value of the resistance S is varied until the galvanometer is balanced. Click the principal button to see how the value of the unknown resistance R is determined. Summary. The Wheatstone Bridge circuit is as shown. When the Wheatstone Bridge is balanced, no current flows between the points A and B. Electric potentials at A and B are the same. R over S equals P over Q. The Wheatstone Bridge can be used to determine an unknown resistance R when the resistances R and S are of the same order. Click on the switch and then click repeatedly on S until the galvanometer gives 0 reading. Click the result button. If the maximum resistance of S is 500 ohm and the resistance R of the unknown resistor is greater than 500 ohm, the Wheatstone Bridge can be used to determine R by changing the value of the ratio P over Q to say 10. Click Switch. Then click repeatedly on S until the reading of the galvanometer is 0. Click the result button. If the minimum resistance of S is 5 ohm and the resistance R of the unknown resistor is less than 5 ohm, the Wheatstone Bridge can be used to determine R by changing the value of the ratio of P over Q to 1 over 10. Click on the switch. Then click repeatedly on S until the reading of the galvanometer is 0. Click the result button. Summary. The Wheatstone Bridge can be used to determine the resistance of a resistor. For a resistor of large resistance, the value of the ratio P over Q is fixed at a large value. For a resistor of low resistance, the value of the ratio P over Q is fixed at a small value. A simple form of the Wheatstone Bridge is the meter bridge. A uniform constant or nichrome wire of standard wire gauge 36 and length 1 meter is used for the ratio arm. A slider or jockey connected to a center zero galvanometer is used to determine the null point. Click the label button. Click the Circuit Diagram button. The meter bridge uses the principle of the Wheatstone Bridge. Click the Precautions button. Precautions need to be taken when using the meter bridge to compare the resistance of the unknown resistance R and the known resistance S. To determine the unknown resistance R, the first step to select a suitable standard resistor of known resistance so that the balance points falls between the 30 cm and 70 cm marks of the slide wire AB. Click on one of the standard resistor to use it as the standard resistor of resistance S in the circuit. Click Switch, then drag the jockey to find the balance point. Repeat for the other two standard resistors. Which is the most suitable standard resistor? Click the 10 ohm standard resistor into the left gap of the meter bridge and the unknown resistor of resistance R into the right gap. Click Switch. Touch the slide wire AB to obtain another set of values for L1 and L2. Then click the Calculations button. Summary. The meter bridge is a form of Wheatstone bridge. When the meter bridge is balanced, R over S equals L1 over L2. Precautions. All connections at the terminals must be properly fastened. Reasons. Loose connections cause the resistance in the circuit to be unsteady. Precautions. The chosen standard resistor should be of resistance such that the balance point should be between the 30 cm and 70 cm marks. Reasons. The degree of accuracy in the measurement of L1 and L2 are about the same. Precautions. Repeat finding the balance point by interchanging the positions of the standard resistor and the resistor of unknown resistance. Reasons. To eliminate N errors due to different resistance at the ends A and B. Click on the meter to view the labels. What type of meter is it? What is its full-scale deflection? What is the resistance of the meter? The milliammeter can be modified to measure currents of more than 1.0 milliampere. Click Switch and observe the reading of the milliammeter. Drag the short length of thick copper wire to connect it across the milliammeter. Explain what happens to the milliammeter reading. Answer. A large fraction of the current bypasses the milliammeter and flows through the copper wire. To convert a milliammeter to an ammeter, a resistor of low resistance, known as a shunt, is connected in parallel with the meter. What is the resistance R of the shunt required to change a milliammeter of full-scale deflection 1.0 milliampere and resistance R1 170 ohm to an ammeter with a full-scale deflection 1.0 ampere? Click on the switch. Drag the slider of the rheostat until the deflection of the meter is full. Click the calculation button to observe the values of the currents. Summary. A milliammeter is converted into an ammeter by connecting a shunt of low resistance in parallel to the meter. Potential difference across the shunt equals potential difference across the milliammeter. The same milliammeter of full-scale deflection 1 milliampere and resistance 170 ohm may be converted into a voltmeter. Click on the milliammeter to pass a current of 1 milliampere or 0.001 ampere through the milliammeter. Click on the potential difference across meter V1 button. To change the milliammeter of full-scale deflection 1 milliamp to a voltmeter, a resistor is connected in series with the meter. Click the voltmeter button. A teacher has converted a 10 milliampere milliammeter with internal resistance 20 ohm to a voltmeter with full-scale deflection of 20.0 volt. Click on the meter to view how the teacher connects the multiplier of resistance R inside the meter. Try to calculate the resistance of the multiplier, then check your answer. When a student uses the voltmeter, which had been converted from the milliammeter by the teacher, what is the voltage being measured when the pointer is at the scale marked 2, 4, 6, 8, and 10? Click on the meter to see the scale of the meter after it has been converted to a voltmeter. Summary. To convert a milliammeter to a voltmeter, a high-resistance resistor, known as a multiplier, is connected in series with the meter.